All right. Hello, everybody. This is Eric Lakin from the University of Michigan, and I'd like to welcome you to today's Sneer CSTI Cloud Storage Technologies Bright Talk event. The topic today is create a smarter and more economic cloud storage architecture. We have three presenters here today who I will introduce momentarily. And they will walk you through some slides. And of course, there will be an option for you to present some questions on the Bright Talk interface. There should be a box down at the bottom. You can submit questions to me, and I will do my best to sort of interject with the speaker at appropriate points to get those questions answered. And then anything we can't get answered on the fly, we'll capture that, and we will work to get those questions answered and answers sent out after the fact. So without any further ado, if I could introduce to you the three speakers who will be talking to you today. We will start off with Alex McDonald from NetApp.
Hi, Eric.
Then Michelle. Hey, Alex, how are you? And then Michelle Tidwell from IBM. Are you there, Michelle? Are you
Hello,
with us,
everybody.
Michelle?
Yeah.
There we
Hello,
go.
everybody.
Sorry about that. And then finally, we'll have Mike Jochimsen from Kaminario speaking. Are you there, Mike?
I am, Eric. Thanks very much.
Excellent. So why don't I turn it over to Alex to get us started. Alex?
Just a few slides before we start. There's a legal notice about warranties, express or implied. Basically, this presentation, if it breaks into two parts, both parts are in your hands. We don't provide any warranties with these presentations. And please be aware of the copyright that exists on this presentation. Sneer reserves the copyright to itself. Sneer itself is an organization with 170 industry-leading organizations, with a large number of storage companies and others, 2,500 active contributing members, and over 50,000 IT end users and storage pros worldwide. It's a big number, and we get out and talk and present to a huge number of people in these presentations and have done so over the previous few years. So what we do is educate, support and promote, understand and collaborate. A very simple set of criteria that we have. The education piece, this is part of it. Support and promoting is about providing people with information, good quality information, and supporting and promoting things that go on in the industry, and obviously collaborating with other industry associations is very important to us as well. The storage, obviously, doesn't stand alone. So the agenda today is you've decided to build a cloud environment. We're going to talk a little about the economic considerations. Michelle will talk to us about the technical considerations. And we'll wrap up at the end with Mike talking to us about the business insights and recap next steps. So without further ado, the economic considerations. In fact, these are really, and this for a technical presentation may be a bit of a surprise for you, but I'm going to talk about money, accounting and economics in particular. And I want to take a little time just to talk about some of the accounting principles and give you an overview of the things that you, as technologists who are delivering cloud solutions, should know. Not in any great detail. We're not asking you to become experts in accounting or economics, but it's essential that you understand the basics so that you can put in place cloud solutions that are cost effective and actually meet the needs of not only your business but their future needs as well. So this needs to have some thought to what it is you're delivering in terms of its economic and accounting activity. So we're going to talk a little today about fixed and variable costs, and in particular Capex and OPEX, that's capital expenditure and operating expenditure, and how you relate costs to storage or storage to costs. And I'll talk a little about quite a useful technique called activity-based modeling or costing that allows you to assign costs to storage in a fairly reasonable and straightforward fashion. And then we'll talk a little about how to calculate on-premises versus cloud costs. I want no arguments, by the way, about on-premises. It's on-premises, not on-prem or on-premise. It's on-premises. Then we'll talk a little about hybrid storage flexibility cost models and some new purchasing and costing paradigms that you might want to be aware of. So, you remember to get an accountant. One of the two things that I always recommend on storage projects, especially cloud projects, are getting a lawyer, because you're going to have contracts to negotiate with third parties, and getting an accountant. It really is important to try and get the money aspects sorted well up front. And you'll find in the beginnings of a project that there's lots of accounting talk, and you might feel a bit left out, and what does it mean? So there's a wide variety of information out there that you can get from the internet. I encapsulated or boiled down today into a brief piece some of the key concepts that you need to have to be able to talk sensibly to accountants and legal people about the economic considerations of putting cloud into place. So first of all, let's get this one that seems to be flavor of the month at the moment. Capital expenditure versus operating expenditure. Now, capital expenditure is the cost of developing or providing parts for a product or a system. So it's actually the initial setup costs. And OPEX, the operating expenditure, is an ongoing cost for running that product or system. Now, that's great information, and a lot of people, and I'm sure a lot of you have heard of OPEX and Capex and moving from Capex to OPEX. And you've got this thing in your head that says, okay, so the cost of providing something is Capex, and the cost of running it is OPEX, right? So when I'm asked to move to Capex, from Capex to OPEX, what I do is, and at that point, it all kind of stops and falls apart. So I want to take you through some of these aspects, just at a high level, so you understand the principles involved. So we've got a nice diagram here, which you should be able to see fairly clearly. If you can't, you can actually expand the screen. On the presentation screen, you'll see there's a make full screen. You can actually expand it out if you want to. And I just want to explain this diagram. First of all, it's a chart that's not based in time. There are no time axes on this. There are two axes. One is costs, how much it costs to do things in dollars or pounds or yen or whatever your local currency is, and the quantity of something you're delivering. In this case, it might be terabytes of storage. And there are a couple of lines on it, so let me take the lines one at a time. First of all, you can see a black line called fixed costs. These are the costs that you have regardless of how much storage you deliver. These are the fixed costs of running an operation in the first place or delivering a service. The red line are the variable costs, which are added onto the fixed costs to produce our total costs. And you can see the gap between the variable and the fixed. These variable costs are things that are costs we bear as we deliver the service. So the more terabytes we deliver, the more our variable costs increase. And sometimes, as you can see with this little step function, sometimes our fixed costs can increase as well, as we have to, for instance, go and buy extra capacity. And then we can draw a line in based on our total costs, what we're going to charge for this, or at least, I'll talk a little about charge back and profit and show back, or at least some nominal value for the storage that we're delivering. And I've marked that dotted line as revenue. So you can see there's a break-even point. To the left of the break-even point, we're in a loss. We're having to provide the basics of a service, but very low quantities, but we're still not making much. We could obviously move our revenue line further up and make it much steeper, but that would make our end product, the amount of space that we're selling, quite expensive. The bit to the right-hand side of the break-even point, underneath the green, is our profit or our margin, if you like. And that we can use to reinvest in the service, or if we're a profit center, we can actually make a profit out of it. The other thing to note about these charts is, I'm going to repeat again, they're not time-based. One axis is cost and the other axis is quantity. But what you might see on a time-based chart is as you deliver more and more terabytes, you might find that your variable costs, the costs of running the service, decline over a period of time. In other words, the first terabyte costs a lot of money, but the 1,000th terabyte might cost you a lot less in terms of its running costs. And we've seen that over the years, for instance, with full-time equivalents, the number of staff that you need to manage a given amount of storage. And that's gone from when I first started in the storage industry, managing 500 gigabytes per person was considered a challenge. And now we're up into the petabyte range per person. So obviously our costs have reduced per byte delivered. So again, over a period of time, you might see these costs decline. But this is a way of thinking about your fixed versus variable costs, about where the margins are, how much you're going to, in quotes, charge for the service that you're providing. So having put that in place, we can now talk about Capex to OPEX. What does it mean to move from capital expenditure to operating expenditure? So the shift to OPEX tries to remove the cost of providing the service in the first place. So let's think about ways we could do that. First of all, we could not run a data center. We'd have absolutely zero costs if we delivered 0 bytes if we're not running a data center. And that first terabyte we need to deliver, perhaps we could go out to a cloud provider and actually provision a service based on buying it externally, and then everything has become operating expenditure. We have no capital expenditure. We've not spent anything at all. But you have to remember that simply moving from capital expenditure to operating expenditure doesn't mean the costs disappear. And in fact, in some environments, in a lot of environments, not having much capital expenditure can actually make for expensive running costs. The running of the service becomes more expensive as the fixed moves to variable. The factor varies. In other words, every dollar spent, for instance, in my data center might require $1.20 spent outside it. That's a factor of 1.2 more expensive as I shift from capital expenditure to operating expenditure. You might see it the other way around, however. You might see a reduction in costs. It depends on your applications and your cost model, and I'll talk about that in a second. So the advantages to variable costs or operating expenditure are they're easier to manage because they're based on consumption and activity. So the more that you do, the more costs you have, but the less you do, the less costs you have. So there's a relationship between the thing being consumed and the amount of money being paid for it. And fixed costs have long payback, or can have long payback periods. It might be 3 years, 5 years for a capital investment that we have to spread that cost out over, and that payback period might be quite extensive. The other advantage of OPEX is if we stop doing it, the cost should reduce to zero. So we can manage much better declining capacity, though I haven't seen that recently, I must admit. The last time I saw somebody using less storage was a long time ago. It doesn't require investment or borrowings. You can pay as you go. In other words, you're not having to borrow the money to make a capital expenditure. It also reduces the cost of being the first. If you remember the diagram, there's this fixed cost that we bear right up front, and there's a cost of being first. That first terabyte or the first 10 terabytes can look a lot more expensive than the subsequent 10 or 20 or 30. And it can often be much easier to sell this to the consumers of your service because you're giving them a fairly simple algorithm. You're saying, it's $10 per terabyte per year, as an example. And if you want 20 terabytes, then it's $20. If it's 30, it's $30. Might even give you discounts if you buy a lot. So it's quite easy to sell to consumers and manage correspondingly. So let's talk a little bit about activity-based costing and what that means in terms of Capex and OPEX. The assumption with activity-based costing is that doing something costs something, but doing nothing costs nothing. And I've already talked a little about that. But it's how you go about identifying the activities and the costs associated with them. So what you need to do when you're providing a service, whether it be a storage service or software as a service or infrastructure as a service, whatever the service might be, then what you need to do is look at all the activities that you undertake to provide that service and all the pieces of infrastructure you need to deliver to provide that service. So you've got several areas or pieces of information that you need. In the scope and planning piece, you need to look at the performance characteristics of what you're providing, because the faster it is, generally the more expensive it is. The I/O loads, the network requirements, all those things that storage has a bearing on, but that are not perhaps directly related to simply storing that byte. Storing a byte is relatively cheap, but moving it there in the first place and retrieving it later also has costs. So there's activity costs based on data movement. There's security and privacy. You may have differing requirements for security and privacy for different classes of data. You've then got provisioning. How do I go about provisioning my storage? What kind of data transmission and network costs do I have? What bandwidth and latency does this application require? And I'll talk a little about these later when we talk about how to go about looking at costs in a hybrid or a multi-cloud environment. And then obviously you've got the aspects of managing and servicing this and looking at growth and maintenance. And last but not least, something that people generally don't think about, the costs of decommissioning. A bit like a nuclear power station, you just can't turn it off and leave it to rot. There are decommissioning costs associated with taking applications down, and you will have to consider those way up front in terms of the project. It may not be possible to look at all the costs, and as we know with nuclear power plants, sometimes we get a surprise at the back end of the lifetime of a particular environment. But certainly we need to think about it up front, because we want to build those costs in terms of the service that we're providing. So we then take all those costs and the activities and we assign costs to each activity. The unavoidable fixed costs we'll have to deal with capital expenditure. And what we're going to try and do is minimize the variable costs, but they are, if you like, the thing that we can do through our operating expenditure. So activity-based costing tries to encourage us to think about the things that we are doing, the activities that we're undertaking, and hence where the costs are coming from in our storage environment, in our compute environment, and our whatever environment it might be that we're putting in place. So activity-based costing and OPEX, there are a few downfalls, and we really need to talk about those. Shared costs. There are some costs that are really difficult to share by activity. Let me give you an example. You've got a data center, you employ staff, and there's a canteen that provides food. How are you going to divide that cost out over the terabytes that you're providing? You might decide to take that cost and simply have it as an overhead cost that you spread out equally amongst all the services that you're providing or all parts of the application or applications that you're providing. So shared costs can be a bit of an irritant because they're difficult to manage and they don't really relate to activity. There are overhead costs that are there regardless of the activity. I mean, just opening a data center, turning the lights on, there's an overhead cost. There are missing costs. Sometimes it's difficult to identify all the costs. There are unrecoverable costs. There are things that you just really haven't got a handle on. But again, a good accountant can help you minimize all these things. Last but not least, however, are behavioral costs. Not all user behaviors are controllable. We know that in storage environments in particular, where overconsumption is the order of the day. People often demand more storage than they actually use. And we've got several ways of dealing with that. We can either charge them. If we're a profit or a cost center, we may want to charge them for their storage use or their application use. And that's a really good thing, unless they're what we call soft dollars or funny money. When we're, in fact, what we're doing is show back. We're simply showing them how much we would have charged them had we been in the business of charging them. So remember, behavioral costs are really quite difficult, and it's very difficult sometimes talking to certain classes of users, depending on your relationship with them, your financial relationship with them, about their consumption, whether it be overconsumption or just poor consumption patterns or demanding high-performance storage when, in fact, it's for archive, that sort of criteria. Those behavioral things are very difficult to control. The other advantages of variable costs or OPEX is against Capex, or capital expenditure. It can be more expensive in the long run. It's sometimes difficult to identify up front what the costs are going to be, but we often see people with large operating expenditures because they haven't made capital investments that would have been cheaper over the time span or the lifetime of the project that they were delivering. And again, reasons for needing an accountant, they can have significant tax disadvantages. You may be able to get tax breaks on capital expenditure or investment, and those things need to be taken into consideration. Overconsumption, underestimating demand can introduce step costs. Remember our fixed step cost there? So you can, in fact, suddenly incur, even with operating expenditure, step costs. You may have to go out, for instance, and renegotiate a contract or add to an existing contract. And you may find that the per unit cost of the new service is actually more expensive than the unit cost you were paying for the old service. So it can sometimes, as I say here, be as significant as fixed costs. But in essence, activity-based costing and operational expenditure are probably the best way to go in terms of managing the costs in a meaningful and cost-effective manner, so you can relate the thing you are delivering to the end user with the cost of doing so. It's much easier than having lots and lots of capital expenditure and then simply divvying out the big bills across some arbitrary quantities. So the other question that we often have is, and I know it's one that Eric Lakin of the University of Michigan, who's introduced this session, and I have discussed in the past, is the cloud cheaper than on-premises? And I think Eric's struggling with that currently, and I think a lot of people do in the on-premises or hybrid or multi-cloud, or, there's so many options available. Which one is cheaper? And the initial reaction that a lot of people have to cheapness is, it's the dollars per gigabyte. Well, no. That's not the cost of providing a storage service or storage to an application. That simply happens to be the raw cost of the unit of the thing that goes up to make the service that you're providing. And it's not a really good indicator of how much it actually costs to provide that service and where that service is best being run. Should it be run in the cloud or should it be run on premises? And my advice here is to try modeling service flexibility. Service flexibility is about the application of the service you're providing and seeing how flexible it is. So to give you an example, can you fragment the service or application into parts? Is it possible to break it into pieces such that each piece can be treated separately, and then we can go and look at the best place to run that individual piece? How fragmentable is the application? What size and type of capacity do we have in terms of our storage requirements? There may be varying storage requirements for a single service or application. We may have online, 24 hours by 7. We may have nearline. We don't really care whether it's offline for a couple of days a week. We might have backup. We might have archive. There are a number of different types and size of capacity that we might be wanting to look at. Even in a single application, being able to divide it up that way. The bandwidth and latency, what width and length of pipes do we need between us and our data center, or between us and our cloud provider? There may be legal and regulatory requirements. We may have protection. GDPR in particular requires that data in the European Union, for instance, very often has to be held in the country in which it's generated. So, there may be a legal or regulatory requirement that you have, and it may be easier and better protected inside your own premises rather than on the cloud, or it may be better protected on the cloud than inside your own premises, depending on what kind of organizational environment you have. There's also the end user location. Remember, the user of the application is not necessarily living in the same place you are, and their geography, their office, and their web interfaces may be in different places with different requirements in terms of responsiveness and in terms of bandwidth and in terms of where the data is held and kept. And then the compute requirement. If you've got really heavy compute requirement, perhaps it's best done on-premise, perhaps. Or if the compute requirement is light, perhaps it's best done off-premises, perhaps. That's very much a decision you need to make in terms of the kind of application that you're running and the parts of the application. And having broken the application up into pieces and looked at its individual requirements, you can then decide the most cost-effective place, because you've done some activity-based costing, hopefully. You can then decide the most cost-effective place to run this service. And it may be the bits of it run, and as you can see the diagram there, there's a sort of knob that you can twiddle and turn to move parts of your application from one place to another. How easy is all this? Well, the answer is not particularly, but who said anything was easy in this environment? It's a good bit of work. One way that we tend to simplify it, though, at the end of the day, for the end user, the person consuming, is to try and provide them with service models. So there are ways of purchasing from you as the provider that might not be as straightforward as just simply purchasing raw bits at the end of a pipe. You can provide them, for instance, with various types of service criteria. Gold, silver, and bronze being three popular designations of what? whatever you decide. Whatever you decide, your gold, silver, bronze, platinum, those type of qualities of service that you want to provide and how you constitute them. Or you could do profile-based charging, where you actually profile an application and say, if the application looks like this, has these kind of characteristics, then here's a charge for doing one of those. So, for instance, in a database environment, you might have a profile for a compute-intensive transaction or a compute-light transaction, but that has a lot of data. So there's a number of ways that you can actually build service models and charge for it and still tie it back to the activity. Cloud brokering is becoming something that we're beginning to see. That's data motion between providers, where I'm trying to make sure I'm getting the cheapest possible service. And I may have 2 or 3 providers, and I may be able to move the data around or the compute around or the data to be able to get the minimum costs for particular kinds of applications. One that's really taking off is data at the edge and data reduction, and that is making sure that if you've got data at the edge, we're generating an awful lot of data at the edge these days. Data at the edge is stuff that's generated outside the data center, or at least not in close proximity to it. And what's happening there is that we're providing compute facilities at the edge to do data reduction and then only moving what we need to move, so that we're actually reducing, for instance, the data down and only moving summaries of the data to the data center. Only if we need the detail do we go out and ask for the detail should the summaries require us to. So there's a different way of looking at the data. Leave it at the edge, crunch it at the edge, move the summaries to the center. Should you need the detail because the summaries, somebody wants to do an investigation, only then move the data. And the other thing that is causing as well is it's causing us to move compute to the storage. So if the storage is out in the periphery, we're often able to move the compute out there because compute is, in relation to data anyway, very much lighter. Data is actually quite heavy stuff and takes a good bit of effort to move. Whereas compute is a bit lighter, a bit more lightweight, and we can move the compute out to the edge and do quite a lot on the storage itself rather than doing it in some centralized fashion in the data center. So that was a brief overview, brief summary of some of the economic and accounting principles. I would encourage you, any storage projects, even ones you currently have, those that are looking at cloud or even non-cloud, it really doesn't matter. Getting an accountant to help you out and work out the most cost-effective way of delivering the service is absolutely essential. And a good accountant will make sure that at least you're spending correctly and spending in a way that you can justify. And I'd strongly recommend to everybody, go out, find a good accountant, and also a lawyer to do all these legal bits and pieces. So with that summary over, I'd like to pass over to Michelle Tidwell of IBM, who's going to talk us through the technical considerations. Michelle.
Okay, thank you, Alex. That was a great overview on costs and cost models. I'm going to talk a little bit about some technical or solution considerations, especially deploying in a hybrid cloud environment. And we're going to go through some of the things that can be done to, create more cost-effective and easier to consume solutions. So if you look at hybrid cloud models, and particularly looking at the storage angle, which is, as Alex mentioned, one of the more challenging parts of the solution, there are, 3 typical types of hybrid cloud models to consider. The first one is around using the cloud as remote storage. So in this case, your primary compute and storage is probably on-prem, but perhaps you want to extend the storage to another place because you've run out of room or you're trying to lower your costs. There's also the consideration of extending on-premises storage to the public cloud for primary or secondary use. So the difference here is that you're actually going to move your storage, your data and your application to a cloud service provider to do something with it. And we'll go through some different use cases there. And finally, the third use case is really on seamless workflow integration between on-prem and cloud. And this is really more of a true multi-cloud environment where a end user wants to take advantage of cloud-native development or applications. So those are the three areas that we're going to dive into a little bit. Okay, so the first one is on using cloud as remote storage. And the use cases for this are typically things like archive, backup, perhaps tiering old data that has not been accessed very often to a remote location. And there are also apps with native object storage support, things like analytics, for instance. And in these cases, it can be quite useful to be able to take parts of your on-prem data and store it up in a public cloud service provider. Now, some of the considerations for this are that, you usually want to target object storage for lower cost. If you look at the cost of something like S3, for instance, it's running around 2 cents a gigabyte. There's some variations on that depending on how much you're storing versus something like EBS block storage, which is about 10 to 12 cents a gigabyte. So although the cost of the storage itself is not the total cost, as Alex went through, it is still can be a very significant part of the cost, especially if you're dealing with large capacities. The other thing to consider, though, is rehydration. So if you're going to use that data or want to use that data in the future, perhaps consider technologies that will allow local rehydration options, actually on the cloud. This can help to avoid egress charges if you need to use that data. So if you have an application, say a database, can't really run against S3 data directly, you need some way to be able to rehydrate that into a block format. For tiering, consider built-in capabilities in the storage arrays on-prem to move that data to the cloud versus gateways. There are many different methods by which to move data from on-prem to the cloud. Many storage arrays today are adding capabilities to actually do it natively. However, gateways are also an option, but that does add additional components to your data center, additional appliances to manage, and a little bit more complexity. Service providers and end users should plan for certain things if you're going to store data in the cloud. One thing is high latency tolerance for apps or in the enterprise. In other words, if you're going to run an application against something that's stored in block storage, and it's a block level application, you're going to endure some pretty high latency to rehydrate that. From a DR standpoint, if you are going to consider using something like S3 to archive or store data, you have to be able to tolerate longer recovery point objective and recovery time objectives to get that data out. Always ensure, and this really goes for any of the use cases, some form of encryption is available, and we've talked about the importance of rehydration methods. So this is the first hybrid cloud model. The second one that we're going to look at is actually extending on-premises storage to the public cloud. So it's different from backup, archive, or kind of storing your data someplace which you may or may not use frequently. In this case, you're really extending the capabilities of your on-premises environment to a public cloud. This could be for disaster recovery or business continuity. It could also be for compute and data offload. It could be for things like test dev or DevOps, where you have application developers that want to easily be able to spin up VMs in an environment where they're just paying by the hour or maybe by the month. And also leveraging the cloud for analytics, being able to put your data in a place where you can run AI or other analytics tools available in many public clouds today. So some of the technical considerations for both service providers as well as end users are, the first one's around performance. Actually, there are a couple here about performance. The cloud data center itself, the network latency, will limit the storage performance to your application in a public cloud environment. There's less control that you have as a user and how that data is connected to compute often, but sometimes there are features to localize subnets of compute and storage within racks, and you want to try to use those where possible. So you don't have a situation where your storage is on one side of the data center and your VMs are on another side, and the latency is causing problems to your performance. Choose a solution that's built for high availability. So there are many data management options that can sit on top of the infrastructure as a service that you purchase from public cloud vendor. Consider using some of these for creating high availability or multi-node configurations. This will improve the underlying infrastructure availability of your solution. And consider the distances between your data center and the cloud data center, and carefully select, the resources on the portals. You want to make sure that you're picking the compute and storage in data centers that are as close as possible, often to your data center, if it is a situation where you're moving workload back and forth. And ensure the data is stored in a way that can leverage cloud services of multiple cloud vendors. Look for solutions which use standard APIs or ways to integrate or use container technology. In other words, you want to go with a solution where you don't get locked into a single cloud provider. You have the flexibility to move that around for various reasons. So just continuing with a few more comments on this particular use case, when you're extending your block workloads, so there are file workloads, block workloads, and there's object, but when you're talking about block workloads, these are typically workloads that are very performance sensitive, latency sensitive. So your data management layer becomes very important, how you're provisioning that storage to the applications. There are various options out there in the market. One of the things you want to look for is an option that provides optimization of the back-end infrastructure. This could be things like dynamic provisioning of high-performance storage when it's needed. That allows you to lower your costs by buying less of the high-performance storage in the cloud service. Dynamic tiering of hot data to faster storage and then moving it back when it's no longer hot. This is another way to lower costs and make sure that you're only using the most expensive back-end storage when the application needs it, and it's dynamic, so you don't have to spend a lot of OPEX and management resources. Having a common management tier between, or facility between on-premises and the cloud can really help streamline the deployment. It can make it easier for administrators so that they can use the same type of operational environment in a public cloud environment as on-prem, and they can maintain that hybrid environment much easier than having to learn two sets of tools. In terms of optimization, and extending block workloads. Some of the technologies to look at are things like data deduplication, compression, thin provisioning, unmapped, auto-tiering capabilities. These can really provide a lot of benefit to the native cloud infrastructure as a service that's purchased. Okay. So the last use case that I'm going to talk about is seamless workflow integration. What do I mean by this? So there are different types of approaches to deploying hybrid cloud and different objectives. There are a class of users and service providers that basically are extending traditional workloads from on-prem to a hybrid cloud or public cloud environment, and that's kind of the use cases that we just spoke about. The other type of use case, and kind of a really growing and really the way that you want to take advantage of clouds in the future, is to utilize native cloud services, to be able to utilize the analytics, get more information out of your data, and really gain the benefits that cloud environments can provide. In this case, you want to bridge cloud native and traditional IT to be able to take your data that exists today and get the most out of it through cloud native apps and also services. This can be helpful to multiple lines of business. It's not necessarily an IT-focused thing. In other words, what you want to do is create an environment where your infrastructure can provide use to multiple lines of business in the enterprise through a single management platform. Some technical considerations here are to use consistent APIs and orchestration across on-prem, private, and public clouds. Technologies like Kubernetes, Docker, VMware, these are some examples of technologies and companies that have solutions upon which you can build such public cloud services and native cloud services. Intelligent data distribution and migration between private and public clouds, so the locality of the data to compute is very important here. And supporting those cloud native environments, you want to consider solutions that can provide on-premises cloud-like experiences with containerized apps and data. Some examples of these are solutions like Microsoft Azure Stack or IBM Cloud Private. These are environments where essentially in your own data center, you can build a cloud type of environment that provides the greatest flexibility so that you can use that on-prem when it's appropriate for you and move that to public clouds if you want to take advantage of other services such as analytics and AI. So finally, just wrapping up here, some takeaways on this section are, first of all, as Alex mentioned, build a cost model. Build a cost model to evaluate the right type of hybrid cloud solution for your business. Run a POC. Many different solutions out there in industry will allow you to do POC and do it for more than a few weeks. Run it for a while to ensure that the solution really fits your use case. Test for things like, do the capabilities meet the advertised features of the solution? Do the performance of the applications work in your hybrid cloud solution? Does the I/O latency meet the requirements for both your on-prem workload and your cloud deployment? And keep in mind when you're running synchronized data and workloads between on-prem and cloud, that can affect your I/O latency on-prem as well. And don't forget about an exit strategy. If the solution is no longer available, or if for some other reason you want to change the cloud service provider, make sure that you have multi-cloud options available. Okay, so that's what I wanted to cover today, and I'm now going to turn it over to Mike from Kaminario.
Great, thanks, Michelle. Appreciate that. All right, so just a quick wrap up here and a little bit of recap from what Alex and Michelle covered. If you are looking to build a cloud environment, whether it is to build a cloud in your organization, your own data center for use within your organization, whether you are a service provider looking to build a cloud and you're going to sell as a service, or if you're looking to build some kind of a hybrid cloud, as Michelle described earlier, you really need to understand both those economic and technical considerations that Alex and Michelle covered. For example, in the economic side of things, it is really important to understand your cost. If you don't understand your cost, how are you going to recover the cost of the storage that you're building? So in your on-premise situation, if you're trying to recover a cost in a chargeback scenario from your organization, or if you're a service provider and you need to recover that cost from your customers, if you don't fully understand all those costs, how will you be able to recover that cost? Then you need to understand your organization's Capex versus OPEX strategy. How are you going to utilize both your Capex and OPEX in the most optimal way? And that's where that accountant comes in that Alex talked about. So, for example, there are leasing standards, FASB 842 and IFRS 16, that are both U.S. and international standards, and these can impact the capital leases that your organization may have. So you need to fully understand how you're going to utilize that Capex and OPEX, whether you're going to procure equipment to put in your data center using a full Capex model, or whether you're going to look at some of the blended Capex and OPEX strategies that vendors are rolling out that will allow you to procure and put storage into your data center or into the cloud and not have to spend entirely Capex for procurement. And also, if you don't have capital to invest and to procure, do you want to, again, leverage some of these models that allow you to move more of that fixed cost into the OPEX side of the equation? There are creative ways to do that, but you need your accountant to fully understand what the impact to your organization is, and especially what the impacts to your tax and legal situations are. And then in the costing side of thing, again, this asset-based or activity-based costing that Alex described earlier can help drive your decisions. If you need to recover costs based on how you incur cost, you, again, first have to understand what are the activities that generate that cost, and are they fixed or are they variable costs. And then finally, Alex talked about some of these emerging purchasing models that can give you more flexibility and creative ways to build a hybrid cloud storage model that spans between your own data center and the public cloud models that are on the market. From a technical perspective, Michelle talked about a number of use cases for the on-premises and the hybrid cloud environments. So understand what use case is the most pertinent to your company. What is it you're trying to build? And also the different file types. What is it that you are trying to store? And what are the unique requirements, whether it's block file or objects? Those all have the different technical considerations. And again, Michelle talked about some of those. Will you be able to take advantage of, or do you need those rich data services that will help you to make more optimal use of your cloud storage, the deduplication, compression, didn't provisioning, et cetera? The common data format Michelle described for portability, and then knowing the performance impact of data locality. So it does matter where your data is placed, whether it's in data centers that are on your premises, data centers that are in your regions, or data centers that may be outside of your regions. You really need to understand whether those are going to provide you the performance that you need for your applications and users. And then finally, you need to really understand and look at how are you going to orchestrate this storage in a hybrid cloud environment, and how are you going to seamlessly manage it? Those are very critical considerations if you're building a cloud environment. So from a next steps perspective, when you're looking to acquire storage, because of some of these economic considerations that Alex talked about, you really need to include your finance team and work out how you're going to find out from your vendors what are your options for procuring storage and how do they affect your overall cost. But first, you do need to understand your cost. So spend time upfront planning, understanding, and uncovering all of the different costs that go into building or using a storage environment. Know your company's strategy for that OPEX and Capex usage for acquiring storage, whether it's on-premises or cloud storage. Again, these can definitely have an impact on your ability to acquire storage over time. And then finally, as Michelle described, really understand which of those hybrid cloud strategies that you're trying to implement, because it does drive a number of not just the technical considerations that she described, but also the economic considerations that Alex described. And with that, I am going to turn it back over to Eric to take us to the finish line. Eric.
Great, thanks, Mike. And also a big thank you to both Michelle and Alex for walking us through their sections of today's Bright Talk. Just a couple of notes. We do value your feedback and input on these SNEA events. It really helps us not only improve in the future, but also to come up with new topics and new ideas that would benefit the community. There will be a webcast as well as a PDF version of these slides that you can get to there on the link on your screen, as well as a full Q&A from the webcast itself, assuming we have a reasonable number of questions. I will circle back just real quick because I saw a question pop up from the audience here as I was speaking. We have a question. The question is, are there any activity-based costing model, building presentations, write-ups, et cetera, available online?
That's a good one, Doc.
Yeah.
I can provide, what we'll do in the back end of the presentation, when we post the presentation online, we'll put something up in the blog that actually covers that. I'll try and dig out some activity-based costing presentations that might be of interest to the audience. We'll put them in as links to on the blog when we write it up this week.
Great. All right. I don't see any other questions coming in. I would like to note as well that you can follow our group on Twitter at SNEA Cloud and certainly engage with us on there as well. So I believe this concludes today's Bright Talk. Thank you very much, everyone, for joining.